Welcome to solverfy.
In this question, we are given a shaft and a plate that rotates with constant angular velocity based on this diagram. Then we want to determine the velocity and acceleration of point C, which is located here. Okay, so and we are asked to express the results in Cartesian vector form. Okay, so the direction of rotation is the first thing that we need to find. Okay, because we need to use the vector relationship of v, omega, and r to find velocity and also acceleration. Okay, so the direction of rotation is along OA. So the vector OA is using Cartesian coordinates. It's going to be 0.3 I plus 0.2 J plus 0.6 K. Okay, and then the unit vector, I'm going to call this direction unit vector, direction of rotation in a unit vector form. So this is going to be minus 0.3 I plus 0.2 J plus 0.6 K divided by the magnitude of the vector. So this is 0.3 square plus 0.2 square plus 0.6 square. And then if you do this calculation properly, you get 1 over 7 minus 3i plus 2j plus 6k. Okay. Then the direction of angular velocity is going to be the magnitude of the angular velocity times the unit vector. So it's going to be 14 times 1 over 7 times the vector. And then this is just 2 times minus 3i plus 2j plus 6k. Okay. And then knowing that the angular velocity is constant, so the angular acceleration will just be it's just the omega dt, and it's going to be 0. Okay. Yeah, so this is something that the angular acceleration is needed for determining acceleration. Okay, then we need to determine the velocity and acceleration of point C. So we need the position vector of point C, and this is actually minus 0.3 I plus 0.4 J. Okay, this is given in the question. So, and I'm going to call this RC. Okay, so VC is just omega cross RC. Okay, so this is 2 times minus 3i plus 2j plus 6k cross with 1 over 10 3 minus 3i plus 4j, and then you have 0.2 times, okay, to do the cross product we will just arrange in a determinant form. Okay, the first vector is in the second row, and then the second vector is in the third row. Okay, and then doing this calculation, we are going to get minus 4.8 I plus minus 3.6 J minus 1.2 K meters per second. Okay, this is the velocity vector at point C. Okay. Okay, next we are going to do the acceleration for point C. Okay, for point C, AC, using the formula, it is alpha cross RC plus omega cross omega cross RC. Okay, so we know that alpha is 0, so the first term is 0, and then the second term is just omega cross V. Okay, this is our V. Then just repeat the same idea. So omega is 2 times minus 3i plus 2j plus 6k, and then our velocity vector is minus 4.8i minus 3.6j minus 1.2k. Okay, so this is 2 ijk minus 3 to 6 minus 4.8 minus 3.6 minus 1.2. And then if you do your calculation, you get 38.4i minus 64.8j plus 40.8k meters per second square. Okay, so this is the acceleration vector at point C. Okay, so just to recap, so this is VC and then this is AC.